So we will continue with linked list. In the previous lecture, we have please excuse me for a moment. So we've looked at the difference between an array and a linked list. We've looked at what a linked list is. How it's created. We've looked at nodes, right? And we've seen, so these were, so the first lecture was basically on the very basics of linked list. Uh, Please excuse me for a moment again. Okay, I'm very sorry for the interruption. Let's start. So these were basically discussed in the very first lecture of linked list. Uh, so today we're going to look at the most important part of linked list, that is how to run a loop over a linked list. As I've mentioned in the previous lecture that linked list does not have random access. Therefore, to traverse or to work with linked list, the only option we have is to run a loop. Without a loop, we cannot actually use a linked list. So if you remember, this is what a linked list look like. A collection of nodes linked together. And I also mentioned about the direction, that we can move from this one node to the other following the direction, right? There are many variations of linked list, but this is the simplest variation where we can move towards one direction. This particular type of linked list is known as singly linked list. Singly linked list. This means singly linked. And the first node is pointed by head. So if for example I have data inside these nodes and I have numbers. So let's start with the very basic operation, that is to print all the elements. When we were working with a linear array or a circular array, for printing all the elements, we have to start from the beginning. We ran a loop that started from the beginning. And we moved by one space, or by one index until we reached the end. So we are going to follow the same basic steps. We'll start from the beginning, that is, we will start from the head. We will print and then move to the next node, print, next, move to the next node, and continue this until we reach the end. Now, as we do not have any index numbers, how to determine the end? So, a question. How to determine the end of linked list, or how to determine the last node? Okay. If you look at the linked list, each node holds the address of the next node. So if this is N1, N2, N3, and N4, N1 will contain the address of N2. N2 will contain the address of N3. N3 will contain the address of N4. And N4 will contain nothing. By nothing, I mean N4 will contain none. Right? I'm quite sure you're familiar with the term none in Python. In Java, we say null. In Python, we say none. And these addresses are stored in a variable. The variable name can be anything, but by convention, we call the variable next. We name it next. So the next named variable of N1 will contain the address N2. The next variable of N2 will contain N3. The next variable of N3 will contain N4. And the next variable of N4 will contain none. And this was my node class. And in the previous lecture, I had already shown how to create a linked list using a loop, right? So for example, I'm not showing it again over here. Say we have created this linked list you see on the screen, and this is created using the class node that contains two variables, value which contains these numbers, and the next variable contain the address of the next variable. So to run the loop, we always start from head, and I've mentioned that we don't want to lose head. Therefore, before we start a loop, we save the value of head inside another variable. Let's say h is equal to head. So I'll work with h. So what should be the condition? The condition should be, as long as I don't reach the end, the condition should be while h, while the variable h does not reach the end, I will print. I'll print and then move to the next object. So there will be another line, move to the next node. So h and head points to the same node in the initially, according to this line. So this is the condition. While h is not equal to none, I've explained in the previous slide that the last variable, the last node contains none in its next variable. So whenever h, I'll move h, I'll use h as my iterator. So h will start from the first node, h will move to the next node. This will keep on moving. And when h reaches this point means none because there are no nodes over here. I'll stop the loop. Therefore, does it make sense that while h does not while h is not equal to none, I will continue to print. Print what? H dot value, because value contains the information and h is the pointer. H is pointing to the object. And we already know that when we try to access a variable using a inside the object, we have to use the dot operator. So initially, h points to the first node and h is not none. I print the first value, h dot value, which is 1. And then I move to the next node. So how to move to the next node? Pretty simple. The address of the next node is inside the variable next. So the next variable of h, right at this point of time, contains n2. So I have to somehow reach from this node to this one using the variable next. Therefore, what I'm gonna write is h is equal to h dot next. This is similar to this line. Remember when we iterate over a circular array, we increment the counter. If c, for example, c is 3, To move from 3 to 4, we add 1 and then save the new value to C again. So C becomes 4. We are doing the same thing in this line. If this is H dot next will give me N2, and this N2 will be saved inside the variable H, which means H will now point to N2, sorry. So H will now point to this variable. So this loop continues. Again, H is not equal to none, correct? Print the value of H. 2 gets printed. H is equal to H dot next means move H to the next node. Loop continues, print 3, move H to the next node, print 4, move H to the next node. Now H has reached none. Therefore, this violates the condition of the loop. Therefore, my loop breaks. While my loop breaks, I have all the numbers printed. So this is the way we're going to run a loop on a linked list. Start from the beginning, do the work, required work, and then move to the next node. Now we keep on doing this until we reach the end. And we always start from the head, but remember, do not use the variable head. Save the value of head inside another variable so that when it changes, head remains pointing to the very first node. Any questions? So any questions? All right. If there
No,
are
sir.
no questions, great. Acha. Acha. Then we do something. Uh, let's say, let's solve this problem. Given an array of numbers, create a linked list using the numbers. Previously, in last week, we had created a linked list using numbers, but those numbers were from the user. Now let's say we have a bunch of numbers inside an array, and from an array we have to create this linked list. So before we move to coding, we will draw to understand the scenario. Okay. So for example, this is my array, and I have numbers inside the array. For example, 1, 2, 3, 4, 5, 6. What I have to do is I have to create a linked list using these elements, using the numbers, right? So this is what is given, and this is what I have to create. The steps remain the same. Step 1, create the first node using the first number. And do this outside the loop, because there's some dealing with the head, right? So I at first I create the first node with the first number and make it head. Second step, make it head. As I am writing the steps, I'm also going to draw, and these steps I'm writing are looking at the picture. So this is what I've done so far. The first two steps, create the first node with the first element inside the array, and I point it with head. Then inside the loop, I create the rest of them and link them up one by one. Third step, inside a loop, create the next node. So far I have created this. Now I start a loop. My loop will start from this particular point because I'm done creating this. So I create a node with the number 2, and let's say this is created inside the variable n. The fourth step should be link n with the previous node. So what I have to do is I have to link n with the previous node. And these steps are repeated until I have created all the nodes. So did you understand the steps? If yes, I'm going to go to coding now. Okay, let's see. Okay, let's write the code. The first line is create a first node. Okay, so I create my node, the first one. Let's say n. Let's say n1 is equal to node. And from the previous course, CSE 111, I think we already know what a constructor is, right? You know what a constructor is? Okay, I bet you guys know. So we will use a constructor to store the value, okay? If this is an array A, I'm going to do this. So using a constructor, I'm sending the value of index number 0, which is the first number, inside the node object, and I create the first node. For example, this is created The first node is created with the first number 1 inside the variable n1. The second step is I have to make it head. So head also points to n1. So the first node is created with head and n1 pointed to the first node. And then I take a loop. Let's say for, I'm writing it over here, for I is equal to 1. I'm done with 0, so I'll start I from 1. I less than length of a, I is equal to I plus 1. So inside the for loop, I create, let's say n2. I create the next node. At this point, I'm creating a node with the number 2 inside it. So this is created and this is created in n2. And the fourth step is link n2 with the previous one. So I'm going to link n2 with the previous one. So previous one is pointed by n1. So n1 dot next will be n2. So this link is created. Now, if you remember from the previous lecture, the previous week, we had to move n1 to this one so that my code over here is consistent. Otherwise, if we do not move n1, if we do not move n1 to the next node, to this node over here, if we do not, the new nodes which we will create will all be linked with this one. So which will end up wrong, right? So I had already explained the reason why I had to move n1 to this one. N1, why I had to move n1 from this node to this one. So please look at the previous lecture. So I move n1 to the next node. So this loop will continue until my I reaches, my I goes beyond the length. When I goes beyond the length, my loop stops, and the result, I'll have a linked list containing all these numbers. So I have a fifth step. So I'll be able to create a linked list using numbers given by the user, and I'll also be able to create a linked list from a given array. In the lab work, you'll also see another question. You'll also see another question where you have to create a linked list from another linked list. I'm going to show you what the process, but I'm not going to show you the code. I'm going to leave the coding part for you. So for example, this is a given linked list, given. What you have to do is create another linked list similar to this one. But this will be a whole new linked list, right? So if this is pointed by head, if the first node is pointed by head, make sure you have a different variable to point to the head of this particular linked list. If this is also head, then this will be lost. Make sure you do not use a variable head or use the same variable to point to this node, two linked lists. One variable can hold the address of one node. Therefore, one variable can point to one linked list. One variable cannot point to two different linked lists. Okay, any questions so far? I repeat, you need to do a lot of practicing, okay? Otherwise, this will be very difficult to understand how linked list works. But once you do enough practicing, linked list will become crystal clear and very, very easy. So we're going to look at a bit more advanced problem, inserting a node in a given linked list. All these problems I'm discussing over here are already discussed in lectures given in box. Okay, I'm discussing them again. So if you have questions, please to ask me over here, because at box there's no way to ask questions. All right. So we have to insert a node in a given linked list. All right. And insert, and where to insert, this will be given. Okay, an index number will be given. Or the position will be given. Now the first question arises is, in a linked list, how can there be index numbers? For example, this is a given linked list. If I say insert this node, this is a new node, at index 2, where is this index number? Linked lists do not have indices, but we will assume that this is not there's not, these numbers, these indices do not exist. All right, we're just assuming that the first node resides in index number 0. The second one has an index number 1, 2, and 3, so on, just like an array. But these numbers do not exist in real. So according to this question, insert this particular node at index number 2 means this node will be, or this node will have, this means this node will have an index 2 in the linked list. This means this particular index node will be inserted in this position, where this particular node will be connected to this one, and this particular node will be connected to this one. As a result, this node will have an index number 2, and these will have 3 and 4. So sometimes this word index is also interchangeably used with the word position. So you're given a linked list and you're asked to insert a node at a particular position. And this example, for example, index number 2. So before we move to coding, I have drawn the picture. If this is a given linked list, and this is the node to be inserted, index 2 means this will be the new links. Now let us look at the steps to be carried out. We already know that this particular node is pointed by head, and we are given the index number. So what I'm going to do is I'm going to run a loop, start from the beginning, and I'm going to move this pointer until I reach the given position -1. So the position given is 2, and I'm going to move the pointer x, and you can name it whatever you want. Move the pointer x until it reaches the node with position -1. So the given position was 2, and I'm going to move this counter from the beginning, and I'm going to stop when x reaches 1. So let's write the code. So I'm going to start I from 0 and move forward until I reach index -1. And every time I'm going to move the counter one node ahead. So I'm going to start x from here, and every time I'm going to move x to the next node, and I'm going to do this until I reaches index -1, and I'll start I from 0. So let us do a little tracing. I starts from 0 and x points to head, while I is less than 1, index -1 is 1. But for this particular example, as I is less than 1, I'm going to move x to the next node, and I'm going to increment I. Is I less than 1? I is no longer less than 1, so my loop stops. At this point, x points to this node. And if you look at the picture, I need to create two connections. One from this one, this is one connection, and this is other connection. So I need, and this is already given. For example, this is n. This node is given, and I need to have access to this particular node to create this connection, and I need to have access to this particular node to create this connection. At this point, I have access to this one pointed by x. Let's say y is equal to x dot next. If this is x dot next will be this one, and this is saved inside the variable, and this is pointed by y. Now I have access to both these nodes. Now I can create these links. Always remember to create this link first. The reason is, as we are in the very beginning, if by mistake we delete this link before creating this, I'll lose everything after this link, because this portion I can reach using the head. But if this link gets erased by mistake, I'm going to lose this portion. So to avoid this problem, what I'm going to do is create this link first. This particular link will be created between n and y, from n to y. Therefore, n dot next is equal to y. This link is created. Now this link will be created from x to n. Therefore, I'll write x dot next is equal to n. This link is created. Whenever this link is created, this link is erased automatically. Why? Because the variable the variable next, can contain only one address. It was containing this address before, and whenever I created this link, the next variable contains this address. The previous one gets erased. That is it. Look at the picture and look at the code. Take a couple of minutes to absorb, and then if there are confusions, please ask me questions. No questions?
Sir, sir, you told to connect the index.
একটু জোরে বলো, একটু জোরে বলো।
স্যার আপনি ওই যে মানে পজিশন 2 এর সাথে নোটটা প্রথমে সংযুক্ত করতে বললেন না?
জি।
এখন আমি যদি সংযুক্ত করি নোড 1 এর সাথে, কি 2 এর মানে ডিসকানেক্ট হয়ে যায় নোটটা?
আমি যদি n এর সাথে যদি 2 সংযুক্ত করি, তাহলে কোনো সমস্যা হয় না। ঠিক আছে?
আচ্ছা। না মানে
তাহলে 1 এর সাথে 2 টা মুছবে না।
আচ্ছা।
তাই আমি এটা করে নিচ্ছি আরকি, যেন ওটা না মুছে।
আচ্ছা তাহলে
তারপরে ১ এর থেকে 2 যেটা, ওটা মুছে আমি নতুনটার মধ্যে কানেক্ট করে দিচ্ছি।
ও জি স্যার, বুঝতে পারছি।
আচ্ছা, আমি একটা জিনিস বলি। যেহেতু আমার এখানে একজন নন বেঙ্গলি স্টুডেন্ট আছে, আমি আসলে বাংলায় বুঝাতে পারছি না। ঠিক আছে?
স্যার সমস্যা নেই, আপনি ইংলিশে বললেন।
ওকে, ওকে, গ্রেট। সো তুমি যদি আমার লেকচারে যাও, যেখানে লাইভ সেশনস গুলো আছে, আমার অন্য সেকশনে আমি বাংলায় বলি। So you can look at those lectures, no problem. Or you may
সমস্যা
attend
নেই।
those classes, no problem.
Yeah.
Okay. Any more questions?
নো স্যার।
Okay. if this is my linked list, or this is a linked list, I can insert a new node in 3 positions. One in the middle, which we already saw. One at the end, I can insert a node at the end. And I can also insert a node at the very beginning. To insert a node in the middle and to insert a node at the end is the same thing. Why? The reason is we do not have to deal with head. But if we add a node at index number 0, which is at the very beginning before head, if we do this, we need to change the head from this node to this one. If we add a new node at index 0, which means the beginning, we need to change the head. We need to change the head. Let's try one. If this is the given linked list and this is the new linked list, this is the new node. And if we are asked to insert it at index number 0, which means this will be the new 0. This was my hand. If this becomes the new 0, I'll have to change, or I have to cancel this head and make this the new head. So the first thing we need to do is, before changing the head, we need to create the connection and then change the head. So if we add a node in the beginning, I just have to create one connection, right? In the previous example, we had to deal with 2 connections because we were inserting a node in the middle. But if we are inserting at the very beginning, we will have to take care with one connection. So and this is quite straightforward. We do not need to run a loop because position 0 means the beginning. That is the head. No need to run the loop. We can easily do this. N.next is equal to head. Therefore, this link is created from N to head. And then I have to change the head and make this the new head. All right, we just write this line. Head is equal to N. This is for inserting a node at the very beginning. And if we are inserting our node in the middle or at the end, we're going to use this, no problem. Any question with insert? Then we're going to look at delete. Similar to insert, we can delete a node from 3 positions: index number 0, middle, and end. While inserting from index number 0, we have to be very careful because the head will get deleted, so we have to deal with head. And deleting a node in the middle or from the end is straightforward. Is like will deal differently. Okay, middle and end will deal it the same way, and beginning will deal it in a different way. So let's look at deleting a node from the middle. So this is my linked list. And for example, the question is, delete the node at index 3. So index 3 means this particular node will be deleted. What are the steps? Always draw first. What we need to do is, in order to delete this one, if we delete this one, for example, if we delete this one, this means there should be a connection between these two nodes, right? So we have to run a loop and go up to this node. That is, if index is 3, similar to add, we run a loop until we reach the previous index, index minus 1. And we need to get hold of this node as well. We need to have access to this one and this one so that I can create a connection between these two. Okay, let us start. So I'll start with x is equal to head, I is equal to 0, and run a loop. While I is less than index minus 1, we move the pointer x and also increment I. So x starts from here, I is also starting from here. While I is less than index minus 1, yes, I is less than index minus 1. We move x to the next node and increment I. I is still less than index minus 1. Increment x, also increment I. I is no longer less than index minus 1, so my loop breaks. When my loop breaks, the variable x points to this particular node. And now we need to get hold of this one. This node. How to do that? Look, x dot next will give me this one, and x dot next will give me this one. So we can write y is equal to x dot next dot next. This is completely all right. X dot next is this one, and dot next is this one. Now I need to create a link from x to y, and that is pretty simple. Whenever this link is created, this link automatically breaks down. Now what about this one? we have to write one extra line, or if we keep it this way, no problem. I repeat again, if we keep it this way, no problem, because when this connection do not exist, when this link does not exist, this link is completely meaningless. So keeping the linked list this way is perfectly okay. So questions? I repeat, this coding is possible when I look at the diagram. If I erase the diagram, for example, if there is no diagram, this will seem impossible. This will seem impossible to code, okay? So I repeat, whenever you're dealing with linked list or any other data structure, especially linked list, always draw diagram and then write your code. Now we've dealt with deleting a node from the middle, and this particular code will work also for the end. So if this is my linked list, if I ask you to delete this node, the last node, same piece of work will work, same piece of code will work. Now let us say we need to delete the very first node. When deleting the very first node, I have to create a link from the first one. I'm sorry. Yes, this is my linked list. And if we need to delete this particular node, the first node, the thing we need to do is simply change the head to this one. If I change the head from the first node to the second node, I can no longer reach to this node. So this is technically delete. Although we are not deleting it from our RAM, but we'll never get hold of this node. So this is the easiest deleting way, but not the best way, because this exists, but we'll lose the address. So best approach will be do this. Take a temporary variable and point it to X. Now change the head. Now change the head. Head is changed. Now I can do this. Sorry. Yeah, X equal to none. When I do X equal to none, this gets deleted from the RAM. Now this is a proper delete. But if anybody writes just this line, delete will work, although not deleting physically. Okay? So if you do not have any more questions, we're more or less done with the basics of linked list. There's one thing I'll do in the next week, additional, that is I'll show you how to create a linked list in a reverse manner. Something I'll show you in the next week. By reverse manner, I mean if this is a linked list given, if this is a linked list, I'll create another linked list, but this time the numbers will be arranged in the reverse manner. This is something I'll show you in the next week. But before you come to not next week, I mean the next lecture, day after tomorrow. But make sure before you come day after tomorrow, you practice all these, whatever shown in the previous week and today. And also look at the lectures uploaded in Box. Give a good amount of time on linked list. Any questions? If there are no questions, I'll end the lecture today.